All right, so if we start with the double angle formulas and we do some work and we rewrite them in a different way, we can get to these identities that give us tools to handle half angles and get rid of exponents. So you'll remember, maybe, depending on when you did the homework, there was a problem earlier that should not have been in there that said tangent of 1/2 of an angle. You would have to use an identity like this in order to, well, actually, you'd have to use both of these identities in order to handle that problem. We didn't have the tools yet when it showed up. So we're going to, real quick, just do a couple of examples using these half angle identities and the power reduction formulas. The first thing we're going to do is we're going to work with the power reduction identity. And what we want to do is we want to be able to rewrite something like the cosine of x to the 4th power without any exponents. And you may be wondering why, because I could just take a root, and yes, you could. This is actually a tool that we will use in calculus in a later term. So this is, remember that the purpose of this, one of the purposes of this class is to prepare you for calculus. This is one of the things that we do so that when we do it in calculus, we will have seen it before. So bear with me. And what we're going to do is we've got an identity that allows us to handle cosine squared, but I've got cosine to the 4th. But that's okay, because I can write cosine to the 4th as cosine squared squared. So cosine squared, I can see, is cosine to, x plus 1 over 2, and that's all squared. So I'm going to pull that 1/2 squared out in front so that I have 1/4 cosine 2x that is not yet squared plus 1 squared. Now let's expand that binomial. So I've got 1/4 cosine squared 2x plus 2 cosine 2x plus 1. Now I can't have any exponents, so I have to do this again. So I'm going to keep the 1/4 out in front. Cosine squared is going to become the cosine of 2 times whatever's in there. So that's 4x plus 1 over 2 plus 2 cosine 2x plus 1. All right, let's distribute our fractions through and simplify some stuff. And what I end up with is 1/8 times the cosine of 4x plus, I've got a plus 1/2 times 1/4 is plus a 1/8 plus 2 times 1/4 is 1/2 cosine 2x plus 1/4. Let's combine our like terms. And what we find is that cosine to the 4th of x can be rewritten as 1/8 cosine 4x plus 1/2 cosine 2x plus 1/4 plus 1/8 is 3/8. And we've eliminated the fractions. Okay, example number 1's done. Let's do something with that half angle formula directly. So what did I do there? I actually used, it's a consequence of the half angle formula, but we call it a power reduction formula. So now what I'm going to do is I'm going to actually use the half angle formula. And I'm going to use the half angle formula because I'm asked to find the exact value of the cosine of 15 degrees. Well, 15 degrees isn't one of my unit circle values. So what am I going to do? Well, 15 degrees is equal to 30 degrees divided by 2. So I'm going to realize that the cosine of 15 degrees is equal to the cosine of 30 degrees over 2. And I'm going to apply the half angle formula. I'm going to apply this one. So the cosine of 2 theta is equal to the positive and negative square root, and we'll talk about which one of those we want in a minute, of, I'm going to write it this way, 1/2 of the cosine of 30 degrees plus 1. Which means that the cosine of 15 degrees, now, which quadrant are we in, even if we multiply, which quadrant is 15 in? That's the first quadrant. Cosine is positive, so we just want the positive square root of 1/2. Sorry, this should be a theta over here. Of the cosine of 30 degrees plus 1. So that's the square root of 1/2. The cosine of 30 degrees is root 3 over 2. Which means that what we really have here is the square root of 3 over 4 plus 1/2. And that is the exact value of the cosine of 15 degrees. It's a little bit ugly because I've got a square root inside a square root, but that is perfectly legitimate. And that is the answer to this question. So that's it for this section. I will see you later with a conversation about section 7.4, wherein we kind of put all of this together and we're going to actually talk about moving amplitudes and midlines. So I'll talk to you again soon.